Hello and welcome everyone to my first video tutorial ever, and this will be about creating a post-process effect that follows your character around when you're moving. And what it does is that it reveals the environment around you progressively, and it uses some noises to create a sort of pattern around the edge. This tutorial, I'd say, is intended for, I don't know, someone with experience with Unreal, but doesn't need to be an expert. I'll be covering pretty much everything there is to know. There is some blueprint involved in this, but it's gonna be very simple and straightforward. So let's get started. So to get you started, well, what you see here, these are assets that I got for free. These are the Paragon assets that are available on the marketplace. So I've just removed a bunch of stuff because my computer couldn't handle having too much stuff in the scene at once. So I've skinned it down to this little area over here, which is all we need. And what I've got in my texture folder over here is a simple noise that I made in Photoshop, really easy, and any noise will do. So let's go back to our post-process folder. And for those of you who've never done a post-process material before, it's pretty simple. It's the same way that we create a material. So let's just create a material. Let's call it PP for post-process underscore sphere reveal or something like that. And let's open this. All that we need to do to make it a post-process effect is to go in material domain and set it to post-process. So we have a post-process material now. Yay. First thing we're gonna do is use a scene texture node. And in the setting here, scene texture ID, we will use post-process input 0. And we'll just for the sake of testing if the post-process is working properly, we'll simply get a desaturation node, plug the color in there, and plug this into the emissive. And let's save. So as you can see here in the viewport of the material, everything's gray already. So I'll just move this aside. Of course, we don't see anything yet because the post-process is not applied to anything. We could apply it to a whole camera, but we're gonna use a post-process volume. So you just go in modes over here, visual effects, and post-process volume. You drag it in your scene, and you just scale this thing up so that it covers the area that you want it to affect. So now we go inside of it, and looking on the right in the details window, let's just scroll down and get to rendering features. This might be closed for now, so just open up the section, click the little plus sign, and we'll click asset reference. And we just drag our post-process over here, and there we go. Now, as long as we are inside of the volume, everything is black and white, because the post-process is actually grabbing the picture. It's almost like it's treating everything that you see in here as a texture or something, and then it applies the modifications that we gave it here. There's probably much more going on in a post-process in the background, but that's my way of understanding it. So let's just let's just save all for now. Whoops. Alright, save all. Okay, so moving on with our post-process, let's just we can leave this aside for now. We can leave it there. So our effect is gonna be world space, and then what we will be doing is give it an offset that will correspond to the player. So what we'll be focusing on at first is simply creating a sphere to have that radius that we need. So let's use world position, and by default the world position the values are really big. So let's just multiply this by 0.001 so that we won't have to be playing with microscopic numbers for the rest of the shader. So let's move this back a bit. Now, how will we create that radius that we need? We will simply, this is being multiplied over here. Alright, we'll be doing a bit of math. So what we need to do is we need to break out the vector. Break float 3 component. So now we have our red, green, blue, which is X, Y, Z, that we can separate from each other. And what we'll be doing is we'll be powering each of these nodes. You can use power or you can multiply it by itself. It leads to the same result in the end, because that's what power is essentially. So power, power, power. And then I think that all we need to do is add those together. This should create a sort of sphere. The values need to be positive because by default power clamps any value that is negative to 0. So let's just call in an absolute node before we plug all of these together. And now if we simply multiply this by, hold on, let's just call in a lerp. Yeah, lerp will do it better. Alright, so we'll have our desaturated color in one input, and then let's just use a component mask, because a scene texture, for some reason it's a vector 4, but we can only plug in a vector 3 in the color. A desaturation makes it so that it becomes a vector 1 anyway, so we didn't need to mask anything here. So let's just plug this here, and we'll be using that sphere as the alpha to blend in between part of the effect which will have color and the one that will be desaturated. And right now the colors are going crazy, probably because we just need to saturate the values to make sure that our sphere goes from black to white and never above white or under black. Alright, we got something. I don't see any result for now. Or is there? Oh yeah, I do see a little gradient. Over here it seems more gray, and over there it seems more blue. Let's just save this as it is. And yeah, it's actually working already. So we've got color over here, and as we get in here, it gets a lot more gray. Right now, it's sort of doing it progressively. It's not like one or the other because of the transition. Let's just, I don't know, let's just do a 1- to reverse the effect. Actually, let's remove that desaturation. It will just lerp between black and everything else. And using that 1-, now the effect is reversed. We get a much better idea of what's going on. Yep. This is a good start. Okay, so we've got our sphere, which is in the world space over here, and if we want to have a good idea of what the shader will be doing, let's just put an add node over here. Let's plug it here, and we will use an append many, and we will put a 0 over here. By the way, when I put a single value like this, I'm simply holding 1 on my keyboard and plugging it in. So yeah, let's put this. Let's put a scalar parameter over here, and this is holding S and clicking, and we'll call this this is green, so Y offset, and let's plug our RGB into this. Let's save it. Let's lower that window, and let's create a material instance of that thing so that we can have easier control. So I like to call them PPI for post-process instance. Just remove the last part of it, and I'll be applying this to my scene instead. So now that I've got this, let's just reduce the window. I've got this setting over here, and I should be able to move. Yeah, see, I can move the effect around. So this is good. So let's put it back to 0. We're gonna delete this anyway, because towards the end we're gonna, when we hit blueprint and we start to make it follow the character, we're gonna remove that thing, and we're gonna set it so that these values that are being fed into the add node are the player position. So by then we won't have like manual control over these numbers. So we can just leave it there for now. It's not really bothering. So let's stop previewing that node over here. Alright, so we've got our circle. Now what comes next? Let me just check, because I've got another instance of the same effect opened so that I can skip ahead in the video and go faster. Oh yeah, now it's the offset. Well, it's more like the radius size. So let's just put an add node after our 1 minus over here, and let's put in a scalar parameter, and we'll call this one radius offset. I like this number better, this word better, because it's not the actual radius, but it still controls it. So now that we've got this offset, let's open up the instance, and let's play around with it. If I do this, yep, see, I can scale it up and down now, but the edge is kind of blurry, and this is not what I want for this effect, so we'll be fixing this. So let's just go back into the main material. God, my computer is rushing right now. Okay. Yeah, alright, so I want something that is really sharp. So a very simple way to do this is to use the floor node. So anything in between 1 and 0 will actually be 0, except for 1 itself. So if we just plug this here, let's put a number here. Oh yeah, see, now we've got this effect where it's either black or it has the color. So let's just save this for now. Now what we want to do is we want to create a sort of border effect to serve as the transition between where everything is black, our black region, and what is not. So let's just create an add node. Let's put this up here for now. So we'll be adding this to another parameter that will be called width. I'll call it glow width, because I'm gonna make that transition glow. Or maybe no, I'll call it border width. case I don't want it to glow. And I will simply be adding this over here. I will also be flooring that. Let's give it a basic value of 0.25. And okay, so now just put a saturate node. Alright, so I kind of messed up in the original recording at this part of the tutorial. So as you can see, I just cut the video a bit, and I just reorganized the scene texture and its mask. And up there I put a color node, which I should have called border color. So let's proceed with the tutorial now. We're just gonna put in a lerp. Whoops, wrong lerp. I think I can just hold L and click. Oh yeah, that works. Alright, so we are going to lerp our color over here, our border color, with the scene texture, and we're going to use the actual radius that includes the border width as the lerp for that one. And then using the same value that we were using earlier to lerp between the scene texture and black, we put this into our value here, into the alpha, and we plug our lerp there, and there we go. Yeah, simple as that. So now we've got our border width over here that we can easily control. Okay, so let's set it to something kind of small like this. And let's just save. Now this is the instance, so we've got this thing over here, and just for fun, let's play with the Y offset. There we go. We've got this nice radial gradient that is really radial in all directions. Oh, okay, and this computer needs an upgrade. So as you can see, there's a bit of a glitch here in the leaves. Not sure what's going on. It has to do with the materials that are from the Paragon assets. I just don't know what's going on, so I'm not going to focus on this. We got this weird white outline. Anyway, it doesn't matter. Alright, so we've got this for now. Now, what would be nice to add to this is an actual sort of noise effect, so that the transition is not so clean. So let's just reorganize this a bit. We will actually move all of these nodes further to the right, and this is where the noise will actually come in handy. So let's actually put this here. Alright, so let's get our texture, our noise texture. So a texture sample parameter 2D, and we'll call this noise or ripple texture. And let's just grab the texture that we have here. Let's put it in. Alright, now we want this to be also projected in world space, so we are gonna do something similar to what we have up here. We're gonna use the world space as the UVs. So obviously we're gonna need actually 3 instances of that texture for each projection. So yeah, we're not gonna use that node actually. Let's use a texture object parameter. The difference between these two is that the texture object can be fed into different texture nodes that will each use their own different UVs. I think that what it does is that the texture is loaded only once rather than being loaded 3 times or something. Maybe not, but anyway, we want to use the same texture for all 3 nodes, so later on when we have our material instance, we can just change the texture in one single place instead of 3 different ones. So that's also a different pro for using this. So we'll just use texture sample. It's not a parameter, so we can plug this in text. So let's go copy paste this so that we have 3 of those. I like to align my stuff properly, make it look good. Alright, now we've got this. We are going to use the same, no, not necessarily the same UVs. So let's just grab these 2 over here, and I don't know, let's change this number to a different number, like 0.5. And now we will be breaking breaking that float 3 into different components. Actually, let's not use this. Let's use different component masks instead. So we're going to need 3 of those. So we're going to use RG over there. Then it's G and B over here. And then it's going to be R and B. Lol. Alright, so now we've got these different projections. We will add them all together. We don't need really a very fancy math over here. Let's just add them all together and divide it by 3 because the value is ramping up to 3 right now. Alright. And then we are going to multiply this by a scalar value that we will call ripple strength. And we are going to add this to our gradient that we have here. Oh yeah, the preview doesn't really work. So before the actual floor calculation. So this should create a bunch of noise. Oh yeah, our value is set to 0 in the strength. Let's put it to 1. Oh, there we go. That's looking interesting. Let's just save this. And let's go try it in our scene. Yep, looking good. Yeah, we're getting somewhere, definitely. Okay, let's save it. What else is there for this shader? Oh yeah, let's give it a sort of wireframe. Well, we're not going to use an actual wireframe, but we're going to project lines in the black section close to the border, just so that it looks like wireframe, as if the geometry is kind of creating itself before being revealed with its color. Oh, another thing, right now the color looks flat. This is because of the moment at which our post-process is being applied. So let's just go down here by clicking in the blank, and in post-process material blendable location, let's set it to before tone mapping. So now that because we have a really bright color, this should actually make it glow. Yeah, because the tone mapper is happening afterwards. So if I change the value here to something much more bright, to something like 20, wait for it. Did it happen? I might have blinked while it happened. Maybe I need to change it here. Oh yeah, 20. What the fuck? Sorry for my language. Oh, okay, yeah. Unreal is sort of adapting the exposure or something. Oh, okay. I'm getting results. It's fine. Alright, maybe a value of 50. Yeah, 50. The color leaks out a bit more like this. Alright. Okay, so we've got this. I'll just pause the video for now. Okay, so for this wireframe effect kind of thing, I think we can simply use our coordinates that we have here. Let's just call it a different node instead. So world space, world position, and we're gonna use a sign. So let's just use a break, no, not component mask. Yeah, a breakout float 3 component. We're gonna use the R value, plug it into sign, and we are going to use a constant bias scale. So constant bias scale, this node, what it does is that it allows you to do an add and then multiply the value. So when you use this combined with a sign, the default values add a 1 to it. So instead of your sign going from 1 to -1, it goes from 0 to 2, and then it multiplies it by 0.5. So now we have a value that weighs between 0 and 1. So let's just round. Let's round that value for now, and let's add this to everything else that we got. So we should be seeing a sort of pattern. Okay, yeah, we are seeing a pattern indeed, and those lines are actually really small. Let's multiply world space values by 0.001 so that we get less lines. Alright, so now we've got these lines over here, which is, let's just play with that number. And also we want those lines to be thinner, so how can we do this? I think we can play with the constant bias scale actually. It's doing 0.5 round. Let's do a floor instead of a round. And we don't see much of anything unless we change the bias to something like 0.6. Alright, yeah, getting somewhere. So now we've got much more spacing between those lines, but they are too far apart. Let's change those numbers. Okay, 0.1, what about 0.05? Yeah, that seems about right. Let's save it and see our result over here. Oh no, it's still too wide. So 0.05, 0.08. Yeah, I guess I'll just go for 0.09 final number. Okay. And if we change our bias over here, we can make them thinner. So right now it's 0.6. What about 0.8? No, that's not what we need. I actually need to put a lower number. A lower number between 5.5 and point whatever. 55. 51. This is good. Yeah, this is good. Alright, let's save this. And we want the color of that thing to be the same as this, so let's just multiply it. Okay, okay. So now we've got this projection. We're gonna do the same thing with a different axis. So let's just move these over here. We are going to have to use these two nodes again. Control C, Control V. We are going to use the green axis and we're going to add them together. The hell? Oh, am I going in negative values somehow? That might be what's going on. Let's saturate these nodes. Before adding them together. Oh, what the fuck is going on? Oh, oh. Yeah, I need to work on my patience. Yeah, I need to add the result after they've been floored. Obviously. Yes. Okay. Yes. Now we've got this. And we also want another projection with our blue value. Our Z axis. Let's add all of these. Let's also saturate the result so that it doesn't go above 1. Put it here. Do we need saturate over here? I don't think we needed it. Let's try. Yeah, we didn't need it. Alright, less nodes. So obviously we're gonna want to mask this afterwards, but now we've got yeah, a lot of stuff. Okay, let's go back over there. Let's solve that problem right away. Alright. So we need to mask this. So this is border width. This is the radius offset. So right now, radius minus border. Well, actually, I just need that. Yeah, I think I just need that. Let's multiply this by that. And if it doesn't work as it is, I'll just do a 1 minus. Yeah, 1 minus. Alright, let's save it. Yeah, that's a bit better. Now obviously we don't want the wireframe to go towards the infinity like this. This is looking a bit weird and noisy. So yeah, it doesn't really look good on geometry that is very that has a lot of angles, I should say. it would look good in a really cubic kind of space, but still, we're gonna reduce the wireframe width. It's still gonna look good in the end. So let's save this for now. So how are we going to mask that effect? We are going to just do another radius kind of thing. Alright, so for the radius of our wireframe, we are gonna put another subtract node right over here. we're gonna put a scalar parameter called wireframe width, could be radius, anyway. And then we are going to, yeah, it will be this, saturated, and we will multiply that result with the other multiply node that we have up here, and save. Is it working already? Did I get it in one single trap? Oh wait, right now it has a 0 width, and increasing it actually shrinks it. Let's put in 1 minus. Okay, so right now with a value of 0 we actually got a 0 width, and if I expand this, it is working. Oh my god, that works. Save. Now let's save this over here. Wireframe width is here, and yep, if I just scale it up and down, I can have it revealed more and more. And then if I use the radius offset, I've got this nice effect going on in there. Yep, I guess that's it. That's it for our tutorial. Oh no, that's not it. Of course, we are going to want to use Blueprint to have this effect actually follow the character around. Yeah, that is much important. So yeah, the Blueprint part of it, it's gonna require something additional too. It's called the material something. Let me just check. It's a material parameter collection. Yep. Okay, so let's close the instance for now. We don't need it. Let's create a folder called material. Oh, what did I just say again? Material component. Oh man, I need to check again. My memory is so short right now. Material parameter component. Material parameter component. Alright. So we'll double click this and we'll create one of those things. We'll call it MPC player position. Now we double click that thing and we've got scalar parameters or vector parameters. We are going to use 3 different scalar parameters because what was it with the vector? Something was wrong. Yeah, I forgot what was wrong with it the first time I did it, but let's just skip it for now. Maybe it can be used, but I don't know. I don't care. So we're gonna call this player X position. I'll just copy that. Copy that name. Player Y position and player Z position. And let's save this. Now we can close it. Now let's just go back here into our offset that we had here, and we can actually call in that material parameter. Oh, I guess it's not the way to do it. What's it called again? Parameter. Collection parameter? Yeah, that's it. Yeah, it has the MPC already selected because it was selected over here. Alright, so let's just yeah, let's just, is it all the parameters that are selected? Oh no, yeah, over here we select X position, and we actually have to copy paste this like that. Over here we're gonna select Y, and over here we're gonna select Z. We're gonna use append mini, bring them all back together into a single vector, and all of this gets added over there. Let's save it for now. All right. So let's close this. I don't think we'll be needing to go back in there. And let's go into our level blueprint over here. So you click the blueprint button up there, open level blueprint. It's gonna load some stuff. Now this is a part where I really need to check the blueprint from my other project to make sure I've got the right stuff. Okay, so we want our effect to be applied. Sorry, we want the effect to be something that is constant. It's not happening just once. So there is this thing called event begin play. We don't need this. We are going to use event tick. So every tick, that means all the time basically, it will do the operations that we are going to create. So first thing that we need to do is get player pawn, and then we get actor location. Dino, what the hell, that must have been something selected in the scene. Alright, so we plug this here, so this should return the vector value of the position that we have of the character. So we are going to set scalar parameter value, and over here you can see it says collection, so that means that you can go set that value directly into the NPC player position that we are also using inside of the material. So the way what we need to do right now, oh yeah, we need to create a variable over here called well, let's just set the variable to a vector, and we'll call this player position. Alright, so we grab player position, we drag it here, and we click set player position. So we need this arrow to be plugged in that one, so that at every tick it does that thing. Now right now it's setting the value to 0, 0, 0, but if we get the actor location and plug it here, now at every tick it will set our variable player position to the actual position of our player. And then what we want to do is we'll get our player position here, get the value. We will break this into different vectors. So break vector, and we will simply, oops, let's just drag this here. We will say this thing is set scalar parameter. We will set our NPC player position X, if you click this here and you put X, to the value X from our player pawn. And we copy paste, and we put this here. We use Y, paste again, and we use Z for the Z one. Alright. And this is all there is to it, to the blueprint part of this. Compile, save, close this, click play, and it doesn't work. because hold on, there is, yeah, it's actually working, but we just need to do a -1. For some reason the player position is reversed or something. So let's just go back into our post-process effect, and we can go in here and multiply it by -1 and save. And now, does it work? Will it work? It does work. Yay. Fuck yeah, man. There we go. We can walk around and reveal the environment as we do. Let's just go back into our post-process, into the shader, and we will give some scrolling speed to our textures over here. So let's just grab all of 3 of these, and let's just simply put some panners. Or if you want to create something that you can actually control through, yeah, okay, never mind. Yeah, we'll create the panners, and we'll create a parameter for control over its speed. Instead of just setting speed inside of the speed, inside of speed x and speed y, we will plug some numbers that we will have control over inside of our instance. So let's just reorganize these a bit for the sake of clarity, and let's do a multiply, 3 of those. Then we'll put let's just put some vector 2. I've got an extra one. Let's say maybe we'll put a speed of 1 over here, 1 over here, and I don't know, -1 over there. I guess we could have used the same value on everything, but anyway. So now let's just create a scalar parameter, and we'll call it scrolling speed. Let's give it a value of 1 by default, and let's plug it into our multiply nodes and save. So now, oh, this is not real time. Make sure it's real time. There we go. We got this crawling type of effect. Oh, that is also affecting this over here. What is going on? Well, it's not bad. Let me check something with our instance. Wireframe width. Huh. So it's also affecting our wireframe, which isn't a bad thing. I just don't like it that much. Let me see if I can make sure that it doesn't affect it. How would I go about with this? Radius offset, this is multiplied, added over there. Actually, what if I just border wireframe? What if I just bring this over here? And I plug the add over there. And over there. So now it doesn't get added into our wireframe width. Well, is it any better? I'm not sure now. Well, anyway, you can do it like that if you want. So wireframe width, Ripple strength, we never really played with this, but if it's set to 0, oh, I guess the minus values also affect it somehow. That's pretty nice. Let's give it a value of, I don't know, 3, 5. Actually, that doesn't look good. Yeah. And it seems that if I crank up the value too much, the border gets smaller and smaller. I guess maybe I can just sort of counter that effect like this. Yeah. Now let's click play. And yeah, much better. Now we see that movement thing. And depending on the texture that you use, the effect will be different on the borders, obviously. So like right now I can see the pattern being multiplied easily, but maybe there's something, maybe you could get that shader, that post-process to go even further by blending in more than one texture to make sure that we don't see the pattern that clearly. And yeah, also that's the effect we get if we go up and down. And yeah, this now concludes this tutorial about how to do whatever it is that we just did. So I guess we should give it a name to that shader. We already called it sphere reveal. It's a bit vague. I'm not sure what this should be called actually. I don't know. Materialize, wireframe to reality, transition. It's getting fancy. Let's just stick with sphere reveal. And I hope you enjoyed this tutorial. And well, this is my first tutorial video, so obviously I don't have much more content. But if you like the quality, well, subscribe to my channel, and I will put more videos up for sure. I'll think of something cool next time. So enjoy doing VFX, video games, whatever it is you're doing. Enjoy life, and I'm out. Peace.